On April 17, 2026, just days ago, NASA sent a command from Earth. It took 23 hours to arrive, 15 billion miles away, traveling through the darkness between stars. Voyager 1 received that command, and a piece of human history went silent forever. NASA engineers just made the agonizing call to shut down one of the spacecraft's vital science instruments, the low-energy charged particles experiment. It had been running for 49 years. It died in a 3-hour sequence. But here is what you need to understand. This is not the first instrument NASA has killed to keep Voyager alive, and it won't be the last. Of the 10 original instruments, 8 are now offline. Only 2 remain, and the clock is running. But in the hallways of JPL, a desperate plan is forming. They're calling it the Big Bang, a high-risk gamble that could save Voyager or silence it forever. I'll show you exactly what that plan is at the end of this video. Losing the LECP is not just a technical footnote. This instrument was Voyager 1's ability to feel the space around it. It measured the ions and cosmic rays streaming through the vast expanse beyond our solar system. No other spacecraft in history has ever been far enough to take these measurements. We are losing data that no telescope on Earth can replicate. So why did it have to happen now? On February 27th, during a routine maneuver, Voyager's power levels dropped unexpectedly. It wasn't a slow decay, it was a crisis. If power drops too low, Voyager's self-preservation mode kicks in. It would have shut down systems randomly, potentially cutting off our ability to talk to it forever. Engineers had to choose: let the spacecraft die on its own terms, or manually kill an instrument to buy more time. They chose the latter. Think of Voyager 1 as an explorer running out of oxygen. Every instrument costs power, and power is the one thing it cannot replenish. Turning off this 1 cent just bought Voyager 1 more year of life. Here is the physics of the end. Voyager 1 isn't solar-powered. It runs on a nuclear battery, an RTG, producing electricity from decaying plutonium-238. At launch, it produced 470 watts. Today, it's down to approximately 270. That is barely enough to power a modern gaming console, yet it is all that stands between Voyager and a frozen, permanent death. Every single year, it loses 4 watts of capacity. It's not a glitch, it's immutable physics. We are now in the single-digit era. Every watt matters. If the heaters fail, the fuel lines freeze. If the fuel lines freeze, the mission ends. While the LECP is now dark, Voyager is still moving through true interstellar space. The 2 remaining instruments, the plasma wave detector and the magnetometer, are still listening. We are still in the void. We just lost one of the main senses we were using to understand it. It is hard to capture what this spacecraft actually is. It has been traveling for 48 years. It has crossed the entire solar system, and in 2012, it became the first human object to leave the sun's influence behind. By November of this year, it will reach a symbolic milestone, exactly 1 light day from home. The distance light itself travels in 24 hours, and it is still whispering to us. Signals at just 23 watts, less power than a refrigerator light bulb, crossing 15 billion miles. Every instrument we shut down is a loss of a sense. When the plasma wave detector goes, Voyager loses its hearing. When the magnetometer goes, it loses its touch. Eventually, the transmitter will go dark. And the most distant human-made object in existence will continue traveling through the silence of the galaxy forever. No one living today will ever see it again. But NASA isn't giving up. Engineers are preparing a final move they call the Big Bang. Instead of waiting for the power to die, they plan to perform a coordinated, one-time reconfiguration of the entire spacecraft. They want to swap out old, power-hungry components for low-power alternatives all at once. If it works, they could find enough budget to keep science instruments running well into the 2030s. They might even be able to turn the LECP back on. But it's a terrifying risk. Any error during this reboot at 15 billion miles away cannot be fixed in real time. NASA is testing the Big Bang on Voyager 2 first, this May and June. If Voyager 2 survives, Voyager 1 is next in July. I'll be tracking the telemetry and the JPL updates daily. Subscribe to Deep Sky Nexus so you're there the moment we hear if Voyager survived the gamble. Which brings us to the impossible choice. If you were on the team and you had to choose between keeping the instrument that listens to the space between stars or the one that feels the magnetic fields, which one would you save? Let me know in the comments. Voyager 1 is still out there, still moving, still whispering. For now.